Greetings, math friends. We are going to look at the partial decomposition of fractions. This is a technique that you may or may not learn in a pre-calculus course, but is useful for integration in a calculus course for attacking rational polynomials that may be a bit more difficult if you don't know how to use this technique. To motivate and kind of give the foundation for this technique, I want to start with something like a fraction you would have seen in, say, 4th grade, and explain the process from this elementary point of view before we move into a more involved view where we have an actual rational function. So what we really want to do is we want to say that I want this fraction to actually be, say, 2 fractions that add together to give me this fraction. Now, from a 4th grade point of view, this might seem like just some kind of exercise to make sure that you understand fraction properties if you would do this in, say, 4th grade. But as we look at the pre-calculus view and then forward, it actually becomes a technique that we can use, again, in integration to possibly make our lives easier. The first thing that we want to do is we want to just kind of establish 2 fractions that are going to add together. The denominator, of course, since we're adding, we have to have something in the idea of a common denominator. But we need it in such a way that when we add these together, we get this denominator. We're going to look at factors of this number. And factors of composite numbers have lots of ways to factor them. Uniquely, they are factorable into prime factorizations. They're unique up to order. The order doesn't matter. And with addition, order doesn't matter either because it is a commutative. So what we're going to do is we're going to factor this into 2 and 3. So 2 will be one denominator, 3 will be the other denominator. And then for the numerators, we are just going to assign variables, say a and b, which we will fill in the a and the b later once we figure out what these a and b's are. So I need numbers here so that when I add these 2 fractions together, they give me 5, 6. And we're going to go through this process not with like guessing or trying to estimate. I want to go through the process that you might go through as if this were a pre-calculus course. So to simplify my calculation, the thing that I want to do is I want to multiply the entire equation by a common term that is going to eliminate the fractions. The thing that 6, 2, and 3 all have in common is that 6 is the common multiple. 1 times 6 is 6, 3 times 2 is 6, and 2 times 3 is 6. So 6 is going to be what I multiply everything by. So when I multiply 5, 6 by 6, the denominators cancel. So let me go ahead and write this out. So everything on the left-hand side multiplied by 6, everything on the right-hand side multiplied by 6. These are canceling. So I have 5 is equal. When I have 6 divided by 2, that is 3. So I have 3a here. And then 6 divided by 3, this is 2b here. So it kind of looks like the denominators kind of switched sides and joined the numerators. So at this point, I need to determine an a value and a b value that I can plug into here so that 3 times a plus 2 times b is equal to 5. Many of you can see what this is going to be because 3 plus 2 is 5. So that basically leaves one option for us on what a and b can be. Now I named a and b 2 different numbers because they were 2 different numerators. But just because we name them 2 different variables does not mean that they cannot take on the same value, which in this case they need to be. If I let a be 1 and b be 1, then this is a true statement. So in this case, I can substitute 1 into here and 1 into here, so that I can make the statement that 5, 6 is equal to 1 over 2 plus 1 over 3. So this should be a true statement. And you can go ahead and do the arithmetic here and verify that that is accurate. So again, this was an elementary view of what we would like to do with rational functions. So we're going to reset here and then look at a rational function and essentially do the same thing. There's a bit more involved with it, but it's essentially using this framework to find the partial decomposition here. So we have a decomposition of this fraction into these fractions so that these add up together to give me this. All right, we've reset. We have this rational fraction here. The same process is essentially going to be our starting point. I need factors of the denominator to set as the factors of the fractions that I break down. First thing we really want to do is to make sure that this is not an improper fraction. The original that we looked at from like our 4th grade point of view was not an improper fraction. We want to check that the order of the numerator is smaller than the order of the denominator. In this case it is. We have a first order function and a second order function, so that this is proper. We have 1 over 2. So it is proper. We're going to set up 2 fractions here. The numerators, again, we're going to call A and B. We're going to fill those in later. So now we have a quadratic here that we need to factor. You can use your favorite factoring method. Again, I have 6 here. We know 2 and 3 multiply together to give us 6. Those are the factors there. But at the same time, we have this is negative and this is negative. One of the 2 factors has to be a negative, since a negative times a positive is a negative in a classical algebra. And then they also have to add up to a negative number. So in this case, we can have x minus 3. We have the larger absolute magnitude being the negative one, so that when we add them together, this is negative. And then x plus 2. Negative 3 times 2 is negative 6, and negative 3 plus 2 is the negative 1. So these are our 2 denominators. So again, just like we did before, we're going to multiply on the left and the right hand side by this denominator. It's going to eliminate the denominator here, and each of these denominators are going to be eliminated, and it again is going to look like these denominators switch sides and join the numerators. So we're just multiplying through by x squared minus x minus 6. So 11x minus 8 is equal to a times x plus 2 plus b times x minus 3. And we're just going to go through the algebra to simplify this. Distribute a property on both of these, and then we're going to regroup. We want to bring all of our x's together, and everything that's not an x is going to be scooted over to the side. Again, all equal to the 11x minus 8. So 11x minus 8 is equal to ax plus 2a plus b x minus 3b. And then regrouping, we have a plus b x plus 2a minus 3b. So I've factored out the x here, and then I've associated these 2 things because I want to look at how these 2 things compare over here. This is, again, still equal to 11x minus 8. The a plus b is the coefficient of x, and 11 is the coefficient of x. So if this thing is equal to this thing, that means that a plus b has to equal 11. Just kind of how we looked before as we looked at the 2a plus the 3b needed to add together to give us the 5. A plus b has to equal 11. Over here, 2a minus 3b has to add together to give us negative 8. So we're going to write that down. A plus B is equal to 11, and then 2A minus 3B is equal to negative 8. Now notice, it's not x and y here, but we have a system of linear equations here. So when I have something like this, I like to just throw this into a matrix, do a reduced row echelon form on that matrix, and then I have the solution that I'm looking for. So we're going to go ahead and do that. So I'm just going to rewrite this as a matrix. So RREF 1, 1, 11, 2, equals 1, 0, So when we do the RREF on this matrix, which is an augmented matrix of this system, it turns out to be this, which means that 5 is A and 6 is B. So we can substitute that back into here. So subtracting out the A and the B, we're going to replace that with 5 and 6. And this will be our partial fraction decomposition of this original rational fraction. If your terms, your factors here in the denominators, if this ends up factoring to something that is something to a power, then there is a slightly different process that happens here. You have different ways of establishing these fractions here, and that is kind of the next level of this technique that you will have to get a hold of, mastery, if you want to use this either for the partial fraction decomposition or for integration purposes. So the next task you would need to learn is what to do when factors here are repeated or to a power, since that's the basic definition of the exponent, is that it's the same term multiplied by itself. Let me throw a problem up here at the end for you to try for yourself. Pause the video, try it, and then restart the video and check your answer at the end. Cheerful Calculations.